In today's chapter, we'll talk about resolution, accuracy and related terms, true value bias, precision and related terms is repeatability and reproducibility. Okay, so accuracy and related term is true value and bias, and precision and related term is repeatability. We'll go a little bit deeper into this. Okay, and that is also called as stability. Let us go through this. Resolution is the number of decimal places that can be measured by the system. Increments of measure should be 1/10 of the width of the product specification or process variation. Let me explain to you this with example. What is the increment that you see on this scale? 1 unit. Okay. So it's very difficult if a part is between 1 and 2, somewhere in between. It is very difficult to tell exactly what it is. Suppose, so this we call as a poor resolution. Suppose if you have a scale like this, which is multiple, it is divided 10 times, okay, so that you can say 1, 1.1, 1.2, 1.3, 1.4, 1.5, right? It is 0.1 unit, 1/10, okay? So this is called good resolution. Suppose if you still want to measure vegetables, what resolution do you have for measuring vegetable? Yeah, least count is the resolution, correct. 50 grams, plus or minus 50 grams maybe, okay. Okay, what is the resolution you have for measuring gold? How many grams for measuring gold? What is the resolution? 1 milligram, right? 0.1 milligram also, 0.01 milligram. So this is called resolution, okay? So least count is nothing but the least unit that you can measure. For gold, probably you can measure 1 milligram. Whereas in a grocery weighing scale, you cannot measure 1 milligram. Okay, so the least count in probably one measuring device measuring gold is 1 milligram. The least count in probably a grocery store is 1 gram, okay, 0.001 kgs or whatever. Okay. Now, does the average of measurement deviate from the true value? A test is accurate at particular time if it exhibits no bias over its full range of measurements. Let me explain to you. Suppose if LKG boys are weighing on the measuring scale, okay, let's say those boys are about 15 kgs or 20 kgs in weight. If primary school boys are all measuring on the weighing scale, and if secondary students and college students are weighing, what I mean by this is, over that range of 10 to 20 kgs, or 40 to 50 kgs, or even 80 to 90 kgs, it should represent the true value, which means that you should not say, if you measure in that weighing balance, there will always be a 1 kg error. It will always show 1 kg more. For example, sugar test. When you always test in a particular 10, people will tell me, hey, this always shows some 20 units more than what I test in the laboratory. Okay, that is called, the variation from the true value is called as a bias. BP range, even oxygen, oximeter, whatever that you take, maybe it will not represent the true value. There will always be some bias. Heartbeat, plus or minus, okay. So the bias is the difference between the average of all the repeated measurements that might be on a sample at a given with respect to its true value. So to avoid bias, you must do calibration with the master standards. So you have a calibration standard to overcome this bias, and you also have something called as a reference sample. In gold shops also, you can always ask them to show the master sample weigh in the measuring scale. If the master sample is actually measuring, say, 10 grams, it should exactly show 10 grams. Okay. Manometer for pressure measurements. So this is called a bias. People can introduce a bias, as I said, that a naughty vegetable vendor who can put a magnet, slight magnet of 20 grams, 30 grams, so that every 1 kg, he can have an advantage of 50 grams measurement. But then the bias is just not artificially introduced. It is because the calibration is not done properly. That bias can get introduced over a period of time, because like your vernier caliper might get loose and your screw gauge might get loose, and petrol pump bias. I have seen that. I have proved in one petrol bunk it and said that yours is always 10 ml lesser than what actually people are giving. Petrol bunk is a very good example. Ration items, great example. Gas cylinders. Okay, I've seen a lot of good examples. I think you have understood bias very well. Let me move on. Okay, accuracy, an accurate test. Let's see with an example of a distribution. Suppose, so distribution of many test values and true values of the sample, and this meets, that means it is accurate. Okay, there is no bias. Suppose if you measure in a different device and it shows a 50 gram difference of these vegetables. Okay, 50 gram, that means it is a bias. The reason between the earlier slide and this slide explanation is I'm showing in the form of a histogram and how the distribution shifts from the true value is what I'm showing this. Okay, I came across this quote. A man with one watch knows what time it is. A man with two watches is never quite sure. Okay, the reason that I'm showing this quote is, I always think if two people come and tell you the reading, okay, suppose if somebody says, how many chocolates are there? He says 45 chocolates and somebody says 50 chocolates. Which will you believe? If somebody says, oh, this guy's weight is 50.5, the other one says that no, it is 51.2. Which one? Okay. So that's why there is this old Chinese proverb which says a man with one watch knows what the time it is. But if you have two watches, you're never quite sure